with a law of sines, there's a couple cases that we need to consider before we figure out our solutions using the law of sines. And you can go ahead and write this down. Keep this in your notes or something that you can refer to during a test, quiz, stuff like that. But it says, when the measures of two sides of a triangle and the measures of one angle opposite them are given, there might be no solution, one solution, or two solutions. So what this is saying is, in the case when we are only given one angle. So this is as kind of a teller. When we're only given one angle of some triangle, that is an awful triangle. But if we're given one angle and two sides, and say the angle we're given is A, for this purposes, I use A as the angle that's given, and the side, the angle, or the side opposite of the angle given is going to be little a. Okay, so you're given two sides. Say you're given little b and little a, and you're given this angle right here. Okay, so if the measure of a, so the angle that's given, is less than 90 degrees, one of four things can happen. And so basically we got to take little a, or we got to take side a and set it equal to b times the sine of a. We know we're going to have a right triangle if they equal each other. If the side a is less than b times the sine of a, no solution exists. If a is greater than b sine of a, and a is greater than or equal to b, one solution exists. And 4 here, if b sine of a is less than b, two solutions exist. So really all you need to do is you need to take this side length b and multiply it by the sine of a, so the sine of this guy, all right? And basically just read your chart here and it'll tell you whether we have one solution, two solutions, or no solutions. So and in the other case, if the angle that you're given is bigger than 90 degrees, if A is less than or equal to B, no solution exists, and that should make sense because the angle that is opposite of the biggest angle in a triangle, obviously you can't have two angles that are bigger than 90 degrees in a triangle, because those two angles would take up more than 180 degrees. So if I had 130, I couldn't have another bigger angle here. So obviously then if B is bigger, then it can't be a triangle because your biggest side has to be opposite of your biggest angle. So if A is the biggest angle, but it's less than another side length, that can't happen. That should be a red flag to you right away. And then lastly, if A is bigger than B, then one solution exists. You will have a triangle, and you can use the law of sines. So here I have an example. I've been given a triangle, and I'm just going to draw any random triangle. It doesn't have to be a right triangle. I'm going to label it A, B, and C. Big A is an angle measure, so 72.23. C is opposite big C, so this is 22, and A is opposite of big A, 21. So basically we're going to look at our chart, and we are going to determine whether we have one solution, no solutions, or two solutions. So remember now, A, the angle that's given is less than 90, so we have one of four things that can happen. So basically we want to look at these options right here. Try to scroll up here. My triangle got cut off a little bit. Regardless, that has all the information we need except for this side length is 21. So basically we got to look at, does 21 equal B sine of A? B is the side that's also given to you, not the third side. So I know it's C in our problem, but in this case, this represents, A represents the side that's given to you. Big A represents the angle that's given to you, all right? And then little b represents the other side. So you're given two sides and an angle. So it'd have to be 22 times the sine of 72.23. Well, first of all, we got to figure out what the sine of 72.23 is. So I got to type in the sine of 72.23, and that is, and take it times 22. Hold on a second. My calculator is in radians. So the sine of 72.23 times 16. All right, so this is 15.24. All right, so they definitely don't equal each other. So it's not 1, all right? There's not a right triangle. If A is less than B sine of A, well, A is not less than that either, no solution, so it's definitely not a no solution. If A is greater than B sine of A, that's true. 21 is greater than B sine of A, and A is greater than or equal to B. Well, is A greater than or equal to B? No, one solution exists. And then in B, if B sine of A is less than A is less than B, two solutions exist. So B sine of A is 15.24, and that is less than A, which is 21, and that is less than B, which is 22. Therefore, we're going to have two solutions. And now I'll show you how to do a problem like that. Okay, so let's go ahead and draw my triangle again. Let's see, A, B, C, and this is 72.23, then this is 21, and this is 22. Okay, so we're going to use the law of sines, which means we have to find this angle right here in order to set up our ratio. I know I tell you to try to stay away from rounded values. Well, now you're probably going to have to when you use the law of sines. We're going to have to use a rounded value eventually. So I know that I can write 21 all over the sine of 72.23, and that should equal 22 all over the sine of C. And then to solve for my angle measure, let's cross multiply. So we have 21 times the sine of C equals 22 times the sine of 72.23. And in order to solve for C, I'm going to divide by 21. And then I'm going to have to take the sine inverse. So C is going to equal the sine inverse of 22 times the sine of 72.23 divided by 21. And let me type that into my calculator. I got to figure out what 22 times the sine of 72.23 is first. That's 20.95 if you're following along, and divide by 21. I get 0.99763 and so forth. And if I take the sine inverse of that, I get 86.05 degrees. So this sine is, or this angle here is 86.06. It's 0.59902. So I rounded up to 86.06 degrees. All right, and then we can continue to solve this triangle by using the law of sines, and obviously, or I could subtract from 180 and solve for B, and then once I have that angle, I can solve for this side length over here. I'm not going to waste all your time because you know how to do the law of sines, you can figure that out. But we found out there's two solutions. So since there's two solutions, what happens is that angle that we just found, this angle 80, this angle 86 point whatever, 86.06, all right? That also could have been, it could have been a different angle. If we would go 180 minus 86.06, that would give us our other angle measure as well. So when you have these cases, you need to solve this other triangle as well, which is to say that you need to solve a triangle that has everything the same, the 72.23, side length of 21 over here, side length of 22 over here. And instead, this angle is now going to be different. In this case, it was 86.06. Or sorry, never mind, I wrote it up here. It was 86.06. All right, so in this case, then it's going to be 180 minus 86.06, and that is 93.9, or no, yeah, 93.94. So this angle is 93.94, and from that, then you can set up the law of sines, and you can figure out this angle as well. So you get two separate triangles, and how you figure that out is you find this one here, the original one you get, then your second option then is to subtract it from 180, and that is when you have your second triangle. So it could have more than one solution, and so basically when this happens, you have to know that you are giving two sides and an angle. You're given two sides and an angle. That's when you need to figure out whether there's one solution, two solutions, or no solutions. Okay? And then here we have a triangle that has A 43, B 20, and all right, so let's scroll up so I can see my cases here. It says that A is 43, I think. And the opposite is 11, and then B is 20, I believe. Okay, so they want to know how many solutions exist for this one. So let's see, this is A, this would be B then, and this would be C. Remember that 43, oh, why did it scroll down there? Ugh. Sorry about that, I had a little technical difficulties. So this is the next example. And they want to know how many solutions there are. And so we're going to go ahead and remember that, and they happen to be labeled A and B already for you, but remember that in this thing right here, A stands for the side that's opposite the angle given, and B stands for the other side that's given. And the big A stands for the angle that's given. It's not always going to be labeled directly A, B, and C. All right, so we know that there's two sides and an angle given, so we actually have these cases that we better check out. We know that the measure that's given is less than 90, so we're up here to where four things are possible of happening. Okay, so we need to check out is A, 11. What is it? I'm just going to put a circle because I'm not sure if it's equal, less than, or greater than, or what, of B sine of A, so 20 sine of 43. So in order to tell, we better figure out what 20 times the sine of 43 is. And we get 13.64. All right, so obviously they're not equal to each other. Now it says if A is less than B sine of A, no solution exists. That is the true statement. It's less than. So no solution exists for this triangle. It cannot be a triangle. So those are two examples that the other link did not have for you. I hope this helps.